Okay, hello, welcome. Today I'm going to be showing you how to do Dijkstra's algorithm in Python. Now, I'm not going to be dealing too much with like the theory or abstract today. I will be touching on it a bit, but mostly it's just going to be the code in Python. So, to start, I do have a little graph that I'm going to show you. A couple things about it. They're all non-negative numbers. They don't have to be whole numbers, they can be fractions or decimals, but the algorithm won't work if even a single one is negative. So this is a directed graph, so A goes to B, but that doesn't mean B can go to A. You can see from the arrows, that's what that means. There are cycles, so loops, you have that. Again, they can't be negative, or else the danger is, it just keeps looping and looping, and then the shortest path will be like negative infinity, and that does not work in computers. So okay, so here's the code. I already made the graph. I already converted it into code. So as you can see, the vertex A is connected to B with weight 10, and it's also connected to C with weight 3. So A to B, weight 10, A to C, weight 3, and so on. So hopefully that's something I understand. And I got a function here, takes in a graph, start node, and a goal node. Today I'm going to do A to D. Okay, let's start off. I already got some empty dictionaries I made. So the shortest distance, it's going to be constantly updated as it goes along, and we're going to set it at a key will be like the node, and the value will be the shortest distance. So it might be like 6 or something, or whatever. The predecessor, we're going to use that to find our shortest path. So when we update it, we're also going to include where that path came from. And so the shortest path from A to C is A to C. At C, we'll have the predecessor be A. Okay. Our unseen nodes, we're just going to set this equal to the graph, all of them. And what we're going to do is run through it all until they've all been seen. So it's an iterative algorithm, so you have to check every single node. That's important. Infinity, I don't know, you just have to choose a big number. It has to be bigger than all your other ones. That's kind of important, but just put a bunch of 9s. And the path, that's just going to be to show at the end. Okay, pretty simple. Okay, let's start off. We have to set all our final distances to be infinity, except the start where we have to set it to 0. So for node in, just do unseen nodes, like the same thing. Shortest distance at the node will be equal to infinity, and then the shortest distance at the start will be equal to 0. So I'll just print this out and run it. So that's basically that, and that's where we are now. So this should be pretty easy. Let's delete that. Okay, so let's start the actual algorithm. So while unseen nodes, this is just a loop, so it's going to keep running till there's nothing in unseen node. So if you're following along from a different language, just go on Stack Overflow and check how to check if a dictionary is empty. But in Python, you just have to write all that, and it'll turn true. So okay, so first things first, this is a greedy algorithm. So when we choose our node that we're going to select, we have to make sure that it has the lowest distance of all of them. So we'll just do a quick check for this. So for node in C nodes, we're going to go through all of them and just check to find the lowest one. First we got to do the base case. So if min node is none, min node equals the node. So this is just for the first case because we have to set it for empty each time, but here's the big one. Else if shortest distance at node is less than shortest distance at the min node. Now we can switch the node. So min node will equal the node we're using. So going through all of them, just finding the one with the shortest distance. So this is in red. So when we run it the first time, it's going to come out as A. Okay, so this next part is like the main part of the Dijkstra algorithm. This is what makes it work. So pay attention to this part, I guess. So now that we have our focus node, we have to check in all of its child nodes and its corresponding weight. So let's just do that. Child node and weight in so this is gonna go, so we're gonna start at A, and then the child node will be B and the weight will be 10. So we have to go check every edge and child node and the weight for each one. So that's just that. And here's the big part. If the weight plus the shortest distance at the min node, if that is less than the shortest distance at the child node, we're going to relax the shortest distance at the child node. So shortest distance at child node will be equal, I'm just going to copy and paste this, and that's basically that. So if you don't understand, I'm just going to do it real quick. So we're going to start at A, is 0 plus 10 less than infinity? Yes. Is 0 plus 3 less than infinity? Yes. Okay, we're going to find the next lowest node. That one's done. We go to C to E, 3 plus 2. So the shortest distance at C is 3, and the weight from C to E is 2. So we add 3 plus 2. That's less than infinity. That is 5. 3 plus 4, less than 10, 7. And that is basically Dijkstra. One more thing we have to do here, we have to set the predecessor of the child node to equal the current min node. And this is just so we can find the path. We don't just want to know the distance from the start, the shortest distance from the start node to the end node. We want to know how it got there. And we need to get the child or the predecessor to do that. And that is basically it. We're in a while loop while true, so we got to make sure we don't stay in that. Unseen node, pop the min node. Okay, and let's just print the shortest distances. So we got B7, D9, A0, E5. Let's just see if that's true. I did this 3, 11, 7, 2, it's 9. That one's this. Yeah, so 7, 9, 3, 5, 7, 9, C. Okay, yeah, that's worked. So one more thing, let's just check the predecessors. And that works. I don't know, I didn't check that one, but let's assume that that worked as well. So that's basically it. Now that's the hard part. Now we just have to write the path out, and that shouldn't be too hard. Okay, let's get rid of this. Okay, now we're just gonna, current node. So we're gonna run through the path backwards and then write down each step we take. So current node is gonna equal the goal, while current node does not equal start. Type it. So this is just going to keep running until we get to the start. But there is a possibility that because we're dealing with a directed graph, doesn't necessarily mean that a graph can, or a node can reach every node. So we'll do a try and catch. Try except. I don't know what language I'm working in. Try except, but I'll get to that later. So we're going to do path dot insert. We're going to insert at the 0th point, and then we're going to put in the current node. Why am I getting an error? Oh, yeah, whatever. Okay, and now we got to set the current node to be equal to its predecessor. So if we start at, let's go, so we start at D, the predecessor is B, I think. We'll switch the current node to B, and we'll find its predecessor, which is C, I believe, and so on. And we'll write it on the path each time we do that. And this should give us the path. I think I'm done here, so I think it's a key error. Print path not reachable, and then we'll just break out of this while loop because we don't need to keep continuing. Okay, now we just got to print it out. If so we're checking if it's infinity, that means it wasn't reached. So we're checking if it's not, and then we'll print, I don't know, shortest distance is okay, and print, what am I doing? And the path is that makes sense, right? I don't know, let's see. Can't convert int string implicitly. And I forgot to add path dot. So we got to add the starter one because it doesn't include that. A, C, B, D, F is 9, sorry. And let's try a couple other ones. E, shortest path is ACE. I think that's right. And let's try E to A. Path not reachable. And there's no way, they're all going this way. Yeah, so the path isn't reachable, just making sure. Okay, so that is, I think that's the right way of doing it. If you see any problem with it, leave a comment, or else people will do it the wrong way. So make sure you correct me, but correct me politely. And I think that's all I'm going to do right now.